we're going to be talking about partial differentiation. So I'm going to be working out some examples of partial differentiation, and because this has multiple variables, this will be the first part here in Cal 1 where we've actually are working with multiple variables. And normally you wouldn't see this until you got to Cal 3 where we talk about multiple variables. However, for some reason in the business course calculus, they cover multiple variables, or they actually just covered partial differentiation. I guess it's just because it's something that they can do, not really having to know much about the theory or definitions or any of that kind of stuff. So I'm not going to talk about any theorems or definitions here. I'm just going to show you some examples, and there is some good geometric things to show to better understand partial differentiation, but I think in these 5 problems or whatever I'm working out here in this section, I'm not really going to talk much about any of that. So we're just going to be doing partial differentiation and just looking at the mechanics. Alright, so I've got my function f here of xy, and it's defined as 2x squared y plus 2y squared x. Let me just say this, that you might try going to some algebra system and graphing this, and at least seeing what the graph looks like. Of course, it's going to be in 3 dimensions. Alright, this notation here, okay, it's not as bad as it looks, I promise. The way this reads is this is the partial of f over the partial of x and the partial of x, partial of f, partial of y, partial of y. Okay, I guess, I don't know, I'm not going to go through all that, but let's look at, I think I worked that one there first. Right, so we're going to be looking at the partial of f over the partial of x and the partial of x. Alright, so which one do we do first? Because you notice we're either going to be doing this one or this one here. So which one do we do first here? Let's scroll on down. You might want to write that down actually. Pause, write that down. Okay, see if I can remember it. I guess never mind, I actually rewrote it here. It's been over a month since I actually worked this stuff out, and I'm just now getting around to recording it. So anyway, we're working this one here, and we're going to be looking for the partial of f over the partial of x. So that's what we're going to do first. And here's our f here. Now, because we're taking the derivative of x, we're going to consider y to be a constant or a coefficient, however you want to look at it. And so what we're going to do is you're going to look for x here, and you're going to take the derivative, for example, of x squared. And you bring the 2 out front, okay, subtracting 1 from the exponent, and now we're left with 4xy plus, and now this y squared, because y squared is times x here, we just treat it like it's a coefficient, okay. So just pretend that this 2y squared right here is just all one single number. Pretend this is just all one single number here. So if this was all one single number times x, then what would the derivative of this be? Well, it would just be this one single number would be left, right? So pretend that's a 5 or something. So 5x, and the derivative would just be 5. But of course it's y squared here. So just pretend this is all one single number right here. Okay, so it's just the coefficient. Alright, now what we're going to do, it looks like I do some simplifying here. Now we're going to take the derivative of it again with respect to x. And so the derivative of x here is 1, but what are we left with? Just its coefficients, which is just becomes 4y. And then this is just a constant right here, and the derivative of this constant is 0. So what are we left with? We're left with 4y. Alright, now what we're going to do is we're going to take the derivative, the partial of f over the partial of y, partial of y. So we're going to do the same thing, except this time we're going to be taking the derivative of y and holding x as either a constant or a coefficient. So the derivative of y here is 1, right? Derivative of y is 1, and then we're just left with its coefficient, which is 2x squared, plus, now you take the 2, bring it out front, 2 times 2 is 4, subtract 1 from the exponent, we're left with y, times, and of course it's just a coefficient, we just rewrite it, x. Alright, so after we have simplified things down, we should be getting 4y. I think I might have already said that. I don't know. What am I doing here? Well, alright, now we're going to do the partial of f over the partial of y, partial of y. I may have repeated this because I had to break this video up into two pieces, so sorry if I already repeated that. But anyway, we're doing the partial of f over the partial of y, partial of y. So we're going to be taking the derivative of y, and you're probably going, well, which one are we taking the derivative of first here? Alright, we'll get to that here in just a minute. But anyway, we're taking the derivative of y. So we're going to hold x as a coefficient. If it's by itself, we hold it as a constant. But so we hold it as a coefficient. Alright, so the derivative of y here, seems like I may have already repeated this actually, but I'm saying it this, I guess I'm just going to redo this. Take the derivative of y, whatever. Take the derivative of y, you get 2x squared. And taking the derivative of y over here, you bring the 2, bring it out front. 2 times 2 is 4. Rewriting the y, and then rewriting the x. Remember, we subtract 1 from the exponent. Alright, now we're going to take the derivative of y again. So the derivative of 2x squared, now see, this is just a constant here. No y's involved, right? Just a constant, derivative constant, 0. And the derivative of y here is 1, and then we just rewrite 4x. We rewrite the coefficients. Okay, let's move on. Alright, now we're going to be taking the partial of f over the partial of x, partial of y. Now you'll see which one we're actually doing first. Well, it's turning out that we read these from right to left. So we end up taking the derivative of this first, and then this guy second. Okay? And so that's the way we did the previous ones, but because there were two of the same variables, who knows. But anyway, so we're taking the derivative of this guy first. So no matter what this is, you always take the derivative of the one on the far right first. Alright, derivative of y. Okay, so we look at this, and, well, haven't we already taken the derivative of y? Well, we did up there earlier, and that was it right here, but I'll run through it one more time. So the derivative of y is 1, and what are we left with? We're left with 2x squared, so we just write it. Plus, and then take the 2, multiply it by the 2 out here, you get 4, subtract 1 from the exponent, so we get y to the first, and then we just rewrite x because it's coefficient. And then now we're taking the derivative of x. So we look at this, so we're taking the derivative of x. So you take the 2, bring it out front, 2 times 2 is 4, and then rewrite x, subtract 1 from the exponent. Now we're taking the derivative of x here. So our coefficient is just 4y. The derivative of x is 1. What are we left with? 4y. Alright, there it is. Partial of f over the partial of x, partial of y. Now remember, we're going from right to left. Okay, this time we're going to be doing the partial of f over the partial of y, partial of x. So this time we're going to be taking the derivative of x first. So the partial of f over the partial of x, we want to look at that first. So we look at this. Well, derivative of x, we got to take the 2, bring it out front. 2 times 2 is 4. Subtracting 1 from the exponent, you just get y, and then rewrite. Right, rewrite the y. Plus, the derivative of x is 1. What are we left with? 2y squared. So that's the partial of f over the partial of x. Now we have to take the derivative of the partial of y. So the derivative of y is 1, and then we're just left with 4x. Remember, you just rewrite the coefficient. And if we're taking the derivative of y now, the derivative of y here is to bring the 2 out front, and you get 4y. Okay, well, we went through all the possibilities here. Now, if you were just given the partial of f over the partial of x, you'd know how to do it, right? You'd know how to do it. So anyway, but I just went ahead and took two partials and went that far. Even if this was like 3 partials here, just remember, or 4 partials down here, whatever, you read these from right to left. So you take the derivative of this first with respect to x, leaving y as right a constant, and then you take the derivative of this one next, right? This time you're taking the derivative of y, leaving the other variables, however many that are involved. You know, we could have a bunch of different variables up here actually. Anyway, so right to left. And I'm going to be introducing some other notation to replace this that I think is easier to understand, but